Hello everyone. In this video we study about the Poisson distribution and normal distribution. So first we study about the Poisson distribution. So the probability distribution of Poisson distribution with the variable x is P of x is equal to e raised to minus lambda raised to x divided by x factorial, where the lambda is equal to mean and this x is the random variable, means this is 0, 1, 2 up to n, and the lambda is equal to np. The value of mean is np here. Now we see how we solve the example of the Poisson distribution. So in this question, in a screw making machine, there are on average 2 defective screws out of 100. These screws are packed in a boxes of 100. Find the probability of a boxes contain no defective, 5 defective, at most 3 defective. So first we can see the distribution is the Poisson. So the formula of the probability of Poisson distribution is x is equal to x e raised to minus lambda raised to x upon x factorial. So to find out the probability, first we find out the mean. So how we find out the mean, because here not directly mean is given in our question. So let's see. So if we read carefully, then we observe that in a screw making machine there is on an average 2 defective screw out of 100. So we know the definition of the probability. This is nothing but the number of samples. This is x is equal to x is number of samples selected from the total number of the samples. So from the out of 100 we select 2 defective screw. So that's why the probability is 100 is 2 by 100. We select 2 defective bulbs from the 100 bulbs. This is nothing but 0.02. Now we know the mean lambda is equal to np, and here the value of n is 100 because these screws are packed in a box of 100. So that's why here the value of n is equal to 100. And now if we put the value of n and p in our formula, then we get the mean. So the value of mean is 100 and the value of p is, we take 2 by 100, because if we select this 0.02, then this is much tricky to find out the mean. But if we select 2 by 100, then directly we cancel this 100 to this 100 and we get mean is equal to 2. So now we put the values in our formula. So first we want to find out no defective screw. So no defective means x is equal to 0. The second sub question is 5 defective. So the x is equal to 5 because we want exactly 5 defectives. That's why we write x is equal to 5. And now the next one is at most 3 defective. At most means maximum 3, not greater than 3. So we want the value of x is smaller than equal to 3, because the condition is at most 3, means 3 and smaller than 3 but not greater than 3. So we calculate here first one, which is nothing but x is equal to 0, no defective. So we put the value. So our formula is e raised to minus lambda. Now lambda's value is 2. Here is the formula. So e raised to minus lambda means e raised to minus 2 into lambda raised to x. Lambda is 2 and x value is 0 upon 0 factorial. So this is comes 0.1353. We calculate this value by using our calculator. Now second one is x is equal to 5. So probability of x is equal to 5. So formula is e raised to minus lambda. The value of minus lambda is minus 2 into lambda raised to x. So value of lambda is 2 raised to value of x is 5 upon x factorial means 5 factorial. Put all this value in our calculator and find out the value. The result, which is nothing but 0.0361. This is the second. Now this is the last one, which is at most. ज़्यादा से ज़्यादा 3, कम से कम कितना भी चलेगा. So p of x is smaller than equal to 3. Now this is nothing but the value of x is equal to 0 plus x is equal to 1 plus x is equal to 2 plus x is equal to 3. So put all this value in our formula. E raised to minus 2, 2 raised to 0 upon 0 factorial plus e raised to minus 2, 2 raised to 1 upon 1 factorial plus e raised to minus 2, 2 raised to 2 upon 2 factorial plus 2 raised to minus 2, 2 raised to 3 upon 3 factorial. So calculate all this value by using our calc. We get 0.353 plus now this is nothing but 0.8571. So these are the probabilities. I hope all you get idea about the Poisson's distribution. Now we see one more example. So here fit the Poisson's distribution of the following data. So this is the given data. Now first we know the formula. P of x is equal to e raised to minus lambda into lambda raised to x upon x factorial. So first we find out the lambda means mean. So how we find out the mean? So formula of the mean is equal to summation of x f of x upon summation of f of x. So here 0 into 109 plus 1 into 65 plus 2 into 22 plus 3 into 3 plus 4 into 1. So when we do all this operation means summation of x and f of x, then we get the value of numerator. So this is nothing but 122 upon summation of f of x. So when we add all this value of f of x means 109 plus 65 plus 22 plus 3 plus 1, we get the value 200, and when we count this value we get 0.6100. And now we want to calculate the capital N, because when we fit the any distribution means Poisson's distribution or the binomial distribution, we know which columns we take. First we take x, then f of x, then the formula means if we want to fit the Poisson's distribution, then we take the formula of the probability of Poisson's distribution, or if the question is for the binomial distribution, then the third column for the probability by using the binomial distribution. And the last one is expected number. So for the expected number, we want to calculate the capital N, and the capital N is nothing but the summation of f of x, and here we count this summation of f of x is nothing but the 200. So that's why the value of capital N is 200. Now we fit all the columns. So here we first take value of x, second column for the f of x, third one for the probability, x is equal to x, and e raised to minus lambda, and we know now the value of lambda is 0.61. So minus 0.61 into lambda raised to x. So lambda is 0.61 raised to x upon x factorial, and the last column for the expected number. Expected number is equal to n into probability. Now we put all this value. So the value of x is 0, 1, 2, 3 and 4. So we write here start from 0, 1, 2, 3 and 4. Now the f of x 109, 65, 22, 3 and 1. So 109, 65, 22, 3 and 1. Now we want to find out the probabilities. So we know the formula, only we put the value of x for each value of x and we find out the probability. So we directly put all this value in our calc and directly we write here the value of probabilities. So first we put the value e raised to minus 0.61 into 0.61 raised to 0, because first value of x is 0, upon 0 factorial we get 0.5434. Now we check the second value of x. So we put the values in our calc. E raised to minus 0.61 into 0.61 raised to 1 upon 1 factorial. We get the value 0.3314. So in the same way we calculate all these value for the each x. So next one is 0.1011, now 0.0206 and 0.0031. Now we calculate the expected number. So value of n is now 200. So 200 into probability of each value of x. So first 200 into 0.5434. We get the value 109. So how we write this integer value directly? Let's see. When we calculate 200 into 0.5438, we get the value 108.68. And if you know the formula, so I hope all you know the rules of how we round off the values. So the nearest value of the decimal is greater than or equal to 5, then we add 1 in the integer value and write the round off value. And if the nearest value of the decimal point is smaller than 5, then we write the integer value as it is. So here 108.68. So 6 is the greater than equal to 5. So we add 1 in 108. And if this value is like 108.26, then 2 is the smaller than 5. Then that time we write 108 as it is. So this is the rule of round off value. Now we check for the next one. So when we multiply 200 with 0.331, we get 6.28. And now if we observe carefully, then the value of 2 is smaller than 5. So we write 66 as it is. We always write expected number in the integer form, not write in decimal form, because when we count all this value of n, means expected number, then we get the original value of n. So that's why it is essential to write the integer value. Now next one, 200 into 0.1011, we get 20.22. Now again, the nearest value of the decimal point is 2 and 2 is the smaller than 5. We write 20 as it is. Now again for the next value, 200 into 0.206, we get 4.12. Again 1 is the smaller than 5. We write 4 as it is. Now 200 into 0.0031, we get 0.62. Now here observe carefully, 6 is the greater than equal to 5. So we add 1 in the integer value and the integer value is 0. So 0 plus 1 is 1. And if we count all these expected number, then we get original value, which is 200. And if this value is not equal to n, then that time some mistakes we do, then recheck the again. So I hope all you get idea about the Poisson's distribution. Now we move for the normal distribution. So the normal distribution, it is the distribution of the continuous random variable x, which is distributed in the bell-shaped curve. So the range of this curve is from the minus infinity to plus infinity. Now the total area under the standard normal curve is equal to 1. Let's suppose this is the midline of the curve and here the value is start from the 0. So the total area under the curve is equal to 1, and this is now the half part of the bell and this is the half part of the bell. So the area under the curve z is equal to minus infinity to z is equal to 0 is 0.5, and the remaining curve, which is z is equal to 0 to z is equal to infinity, the value of the area is 5, and when we add both these two equal part, then we get the total area. And so for the normal distribution, first we want to calculate the value of z, and this value of z is nothing but x minus mu divided by sigma, where x is the random variable, mu is the mean, and sigma is the standard deviation. So here the first example is the income distribution of a group of 10,000 person was found to be a normal with mean rupees 7,500 and the standard deviation is rupees 500. What is the number of person of this group who has income first exceed rupees 6,680, exceed rupees 8,320, and this is the given of the area, means area under the standard normal curve between the coordinates plus minus 1.64 is 0.8990. Now we see what is the meaning of the question. So if we read carefully, then we see the values of the mean and the standard deviation is given. So mean is rupees 7,500 and the standard deviation is 500. So mu is equal to 7,500, sigma is equal to 500. So mu is equal to 7,500, which is nothing but the mean, and the standard deviation is 500. Now we see in the next, we know only one formula, which is z is equal to x minus mu upon row. So now we know the value of mean and the standard deviation, and the value of x is come from this sub question. So first sub question is exceeding rupees 6680. So the value of x is equal to 6680. Which value we want to find out? Write x is equal to that value. So first condition, the x is exceed means greater than 6680 rupees. So first we find out the now z. So z is equal to x minus mu divided by rho. So value of x is 6680 minus rho is 7500 divided by rho is 500, which is equal to minus 1.64. For the first problem, we find out the value of z. Now draw the curve, bell shaped curve. Once the draw the mid value. Now in the left side the value of curve is 0.5, and the left side of the mid line the area of the curve is 0.5. Now let's suppose this line is represent the number line. So here is the 0. All these negative value are at the left side and all these positive value are in the right side. So which value we calculate for the z? If this is the negative, then the draw at the left side, and if the calculated value comes positive, then the draw for the right side. Now this is for the left side because this is the negative value. Draw the line of the z. So here the value of z is minus 1.6764. Always remember, draw the curve for the value of z, not for the value of x. Now one more thing, the p of x equal to x is always equal to p of z is equal to z. So which is the value of capital X? This is similar for the capital Z, and the value of small x is similar to the value of Z. So if the x is greater than 6680, then the value of z is also p of z is also greater than equal to 6680, and which is nothing but the value of z is greater than minus 1.64, because for the x we calculate the value minus 1.64. So if this is the value of x, then the value of z is minus 1.64. So we now calculate the probability for the z is greater than equal to minus 1.64. Now we know at the left side all the small values are the present, and at the right side all these greater values are the present, because here all the positive values are the present and here all the negative values are present. And if we want to find out the value of z which are greater than equal to minus 1.64, then the portion of the curve which is this, which I shaded here, so this is the part of the curve which is greater than minus 1.64. So we want to find out the area of that curve. So how we find out now this area of the curve? We know the right side of the midline is 0.5. So that much portion we find out, 0.5. Now only we find out the area of the curve 0 to minus 1.64, and once we get the value of this portion, then this portion we added into right side, then we get whole the area of the curve which is greater than minus 1.64. So if we read the question carefully, the area is given, but this area from the positive 1.64 to negative 1.64, and we know the area of the bell shaped curve is divided into two parts equally, means left side is 0.5, right side is 0.5, and if the area between the positive value to negative value is that much, then the half of the value is divided by 2. Means we draw one more curve for our understanding. This is the midpoint, and in the given they gives us area of the curve start from minus 1.64 to positive 1.64. This shaded portion is given 0.899, but we don't want this whole portion, we want only 0 to minus 1.64, and as I said, the midpoint is divide the curve equally, the left side 0.5, right side 0.5. so similarly here 0 to minus 1.64 is equal to 0 to 1.64. so for that we divide the curve 0.899 divided by 2 to get the value which is only for the 0 to minus 1.64. so this is nothing but 0.4495. so this value only for the minus 1.64 to 0, and when we add this 0 to 1.64 means 0.4495 plus 0.4495, we get whole area which is 0.899. Now we know the area of that much curve which is 0.4495, and now if we add this portion with the right side, then we get whole the area. So if we want to find out the area which is greater than minus 1.64, then we add the half of the 0 to minus 1.64 and 0 to infinity, we get the whole area. And if we want to write the technically, then we write P of minus 1.64 is smaller than Z is smaller than 0 plus P of 0 is smaller than Z is smaller than infinity. So we know the area of that portion which is 0.4495 plus 0 to infinity, the area is 0.5, and then when we add this we get 0.9495. so this is the area of the curve which is greater than equal to minus 1.64, means this is the value of the x which is greater than 6680. So in this way calculate the probabilities for the normal distribution. Now the second, exceed rupees 8320. So here again exceed means value of x is greater than 8320. Now we find out first the value of z. So z is equal to x minus mu divided by rho. So value of x is 8320. Put the value of x which is given for the calculating value. So minus the value of mu is 7500 divided by, now the value of rho is 500. and when we calculate all this term we get 1.64. Now here positive 1.64 is come. So first we draw the curve. So this is our curve which is divided by the midpoint. So each part of the left side and the right side is 0.5. Now we draw the line for the z, and now this is the positive, so we draw at the right side. So this is the value of z. So z is equal to 1.64. This is start from the 0. Now we want to find out the value of x which is greater than 8320, and as I say, if this is the x is greater than 8320, then the probability of z is greater than 1.64, because these are the similar terms. So we want to find out the value of z's which are greater than 1.64, and we know the value of z are the greater for the right side and smaller for the left side, because at the left side all the negative values are the present, and in the right side all the positive values are the present, and we want to find out now that portion. So value of z are the greater for the right side of the portion. So how we calculated that portion? So simply, as we know, if we subtract this portion from the whole portion, then we get automatically the remaining portion. So as we know, the right portion of the curve is 0.5, and if we subtract the area of the curve from the 0 to 1.64 from the 0.5, then we get the remaining value. So first we find out the area of the curve under the 0 to 1.64. As we previously discussed, we know the value of the area of plus 1.64 to negative 1.64, and this is, and the midpoint is divided equally between the curve. And if we know the whole portion of the area and we divide by the 2, then we get the half portion of the area. So here each area of the 0 to 1.64 is equal to 0.4495. So this 0.4495 plus this 0.4495, we get total area 0.899. So this portion is 0.4495. So if we subtract this 0.4495 from the 0.5, then we get the remaining value. So how we write this? So P of x is greater than 8320 is equal to P of z is greater than 1.64, and this is nothing but the portion the portion 0 is smaller than z is smaller than infinity. This is nothing but the right side minus the value of area under the 0 to 1.64. So 0 smaller than 0, z this smaller than 1.64. So area between the 0 and 1.64, and this is the area between the 0 to infinity. So this is the 0.5 minus this area is 0.4495, and we get 0.0505, which is the remaining area, which is greater than 8320. In this way we find out the probability of the normal distribution. Now we see one more example. Here the value of mean and the standard deviation is given, and we want to find out the probability between the 0.496 to 0.508. So how we find out? Same, first consider the given value as a x. Now here the two values of the x are given. So first suppose this is the x1 and 0.496 and the second value for the x2. So this is second value and this is 0.508. Now find out the z for each value of x. So this is suppose z1 and the value of z1 is x1 minus mu divided by rho, and value of z2 is equal to x2 minus mu upon rho. Put the values. So x1 is equal to 0.496 minus 0.00, sorry, this is not, the value of mu is 0.502 divided by 0.005, and this is 0.508 minus value of mu is 0.502 divided by 0.005, and which is nothing but minus 1.2, and this is the positive 1.2. Once we find out the value of z, then draw one curve. By using this curve, quickly understand which portion means which area we want to calculate. So first calculate the value of z by given value of x, and then draw the curve, draw the midpoint, midline, which is start from z is equal to 0. Now as I say, at the left side all the negative values are the present, and at the right side all the positive values are present, and draw the curve for the z, which z we find out. So this is minus 1.2 is now draw at the left side, and this positive value of z draw at the right side. So this is z is equal to 1.2 and this is z is equal to minus 1.2, and we want to find out the portion between these two values. So this portion we want to find out, this portion. In the previous question itself, in question the area is given directly between the two values, or suppose many times given the values z is between the 0 to 1.2 is this, that, but if the area of the curve is not given, then that time by using the normal distribution table we find out the area. So how we find out this area? So from the normal table, see the column of the first where the all the values are the given. These values are start from the 0 to infinity. First see the value and refer the first column. Go for the row where the 1.2 is written, and as I say, this curve is equally divided. Then if the positive value is suppose 2, then the negative value is also 2, but this value is negative only. The difference is between only that. So refer that normal table. Observe the row where the 1.2 is written, and this 1.2 here now the value is only 1.2 and 0. After the 2 all these value are the 0, that's why we not written here. And if the value are that like means 1.248, then how we find out the area? That time we refer the first row where the 1.2 is written, and the next value, if 8 is right, then we see the column where the 0.04 is written, and we refer that 0.04, and this 0.04 column and this 1.2 row where that values are the intersect, this value is nothing but the area of that portion. So if we want to find out 1.2, so that's why we refer the row of 1.2 and the column of 0 0, because after 2 no any value is written, means 0 0 is here. So the area of 0 to 1.2 is 0.3849. We can see here. So value is 0.3849. Now this portion is, now we know with the help of the normal table we find out the portion is 0.3849, and if this positive area is 0.3849, then the negative area is also 0.3849, because the value are the same, only the signs are the change. And no, we not count the area in the negative values. So if we want to find out the area between the minus 1.2 to 1.2, then this 0.3849 plus this 0.3849, we get whole the area. So how we write? Here first we want to find out the area between the 0.496 is smaller than x is smaller than 0.508. This is the question. And if we write this in the z form, then we write p is minus 1.2 is smaller than z is smaller than 1.2, because for the value of x1 we get the value of z is minus 1.2, and this value of x2 we get the value of z is 1.2. So this is nothing but the value of z is between the minus 1.2 to 0 and 0 to 1.2. Minus 1.2 to 0 plus this 0 to 1.2. 0 to 1.2. So the half portion is 0.3849 plus this half portion is 0.3849. We get total area, which is 0.7698. So I hope all you get idea now how we find out the area. Now we discuss some cases. How many types of the questions are they asked? Which various types of the questions are the possible on the normal distribution concept? So previous two question we see the two types, means one type is if the we want to find out the value of x which is greater than something. So how we calculate? We refer all this right side of the portion, and if we want to find out the value of x between two values, then what we do? We find out the x1, x2, z1, z2, and we find out the area of the portion. But if the question is like find out the value of x which is smaller than something, suppose 2, then how we find out? Then that time first is as it is find out the value of z and draw the value of z. If the value of z is negative, suppose here the value of z is come and the question is like below the value of z. So below means smaller, and all the smaller values are the left side of the portion of the curve. So if the question is like find out the value of x which is smaller than minus 1.2, so smaller of minus 1.2 portion is at the left side of the line. If the value of, if we want to find out the value of curve, the value of z is minus 1.2, and we want to find out the value of the area which is greater than minus 1.2, then we calculate this portion which is greater than minus 1.2, and for that this portion we know 0.5. Only calculate the remaining portion and add both this portion, we get the area which is greater than minus 1.2. Now again, let's suppose the value of z comes positive and we want to find out the area which is below the plus 1.2. For our understanding, we assume the value of z is 1.2 and we want to find out the area which is below the 1.2, below or the increment, decrement, that like words if used, then that time refer all these values which are smaller than the value. So if we want to find out the value which are the smaller than 1.2, that time that portion we have to find out. Again, how we find out? We know the upside which is 0.5 and only calculate the remaining area which is from the 0 to 1.2 and add both this value, we get the total value. Now if we want to find out the value which is at in increment or over the 1.2, that time find out the area at the right side. So how we find out this area? Subtract the area of 0 to 1.2 from the 0.5, because we know the upside of the curve is equal to 0.5, and once we subtract the value which is from the 0 to 1.2 from the 0.5, we get the remaining area. These are the case for the below. This is also for the below. This is for the over. This is for the over. And we know how we find out the value for the between two values. We can write here. If we want to find out that this portion, we subtract 0.5 minus a. Let's suppose this portion is a, then we get the remaining portion which is our probability. If we find out the area of this, then what we do? 0.5 plus, let's suppose this portion is a, so we get the remaining our probability. If we find out this portion, then we subtract the 0 to minus 1.2 area. So this 0.5 minus, suppose this area is a, we get the remaining portion, and for that this condition we add 0.5 plus this portion of area which is a, we get required area of the portion. So these are the possibilities of the question which are asked on the normal distribution concept. We see one more example. So the question is 7% items are under 35 and 89% items are under 63. Find the mean and standard deviation. If we observe carefully, then in the previous question we know the values of the mean and the standard deviation, but in this example we find out the mean and the standard deviation. So how we find out? Let's we see. For that, first draw a one curve. This is our normal distribution curve. This is our midline which divide the curve into two parts, equal two parts. Now let's suppose this is the 100% of the curve, and if this type of the question is given in the percentage, then suppose the given portion is the 100% and the 35 now is start from here 0 to 100. So the 35 we draw at the left side. So let's suppose this portion of the 35. So here is the x is equal to 35 and this is the 7%. So this portion is our 7%, and 7% we write 0.07, because 7% we know 7 divided by 100, and which is nothing but 0.07. Now if the whole portion is 100, then this half portion is 50, this half portion is 50, and from the 50 if we put this 7%, then the remaining is 50 minus 7. 50 minus 7 is equal to 43%, because from the 50% of the portion we assume this 7%, so remaining portion is 43%, and which is nothing but 0.43. Now we move for the forward. So 89% items are under the 63. Now the 63 we draw at the right side, because this is the greater than 50 and 35 is smaller than 50. Here is the half of the curve, so 35 is smaller, so that's why we draw at the left side. Now 63 is the greater, so we write at the right side. So this is the 63. Now in 63%, 89% of the item, so this portion is 89%. Portion means whole portion which are smaller than 63, because read carefully, under the 63, here under the 35, under means smaller, so this smaller part is 7%. Now 89% for what? Whole the area which is smaller than 63, means this positive area plus this negative area, because this negative area is also under the 63%. So this whole portion, negative plus positive, is 89%. So how we find out only that much portion, positive portion? We know this portion is 50% and the whole portion is 89%. So 89% is equal to x plus 50. This 50 plus, suppose this is the x, we get 89%. So 89 minus 50, we get 39. So this positive area is now the 39%. This 89% whole the area which is under the 63. But if we only want the area which is from the 50 to 63, this is 39%. And 39% is nothing but 0.39. And if this portion is 39, then the remaining is 50 minus 39, which is nothing but the 11%. So this is the 11% of the portion, which is 0.11. I hope up to this all you get the idea about the question. Now one more thing we missing here, the area are the given in this question. So the area are between the z is equal to 0 to z is equal to minus 1.48 is equal to 0.43, and z is equal to 0 to z is equal to 1.23 is equal to 0.3907. These values are the given in our question. So here now we know z is equal to x minus mu upon rho. So we know the value of x is x1 is equal to 35 and x2 is equal to 63, because two value of x we know. Now z, so which value we suppose for this z is 50 to 35. The area is 0.43 and which is given here also 0.43. So let's suppose this 0.43 for this value, because we count all the values. This portion for the area is 0.09, this portion is 0.43, the next portion is 0.39 and remaining 0.11. So these values are also the area, and this value we find out these are also area. So for the 0.43, the value of Z is minus 1.43. Analyze this value of area and this value of area, and which values are the similar, put that Z for the calculation. So now the Z1 we put minus 1.48, because the portion of 0.43 is equal to minus 1.48, which is given here. So this Z1 is equal to value of X. For this Z, the X is 35. 35 minus mu divided by rho. And now for the Z2, again which value of area are the similar to the given area? This is 0.39. Here is also 0.39 we see. So for that the value of Z is 1.23 is equal to value of X is 63. This portion of the Z is, the area is 0.39. So that's why we put the value of X is 63 minus mu divided by rho, because we want to find out the mean and the standard deviation. Now we have two equations. So we solve these two equations. So we transfer this rho at the left side. So this minus 1.48 rho is equal to 35 minus mu, and again we transfer this negative mu at the left side and this negative value at the right side. So mu is equal to 35 minus this, now minus is transferred in the plus. So this 35 plus 1.48 rho. So this is our first equation. Similarly we perform here. First we transfer this rho. So 1.23 rho is equal to 63 minus mu. Now we move this negative mu at the left side. So this is converted into positive. So mu is equal to 63 minus, because this is the positive value. When we transfer at the right side, it converted into negative. So 1.23 rho. So this is our second equation. And when we solve these two equations, we get the value of mu. So we subtract equation second from the equation 1. So mu is equal to 35. We subtract 1 from the 2 or 2 from the 1, no any issue. So 35 plus 1.48 lambda minus this mu is equal to 63 minus 1.23 rho. So this mu get cancelled. Here 0 is equal to this 35 minus 63 is negative 28, and this 1.48 minus this minus get plus, and this 1.48 plus 1.23 is equal to positive 2.71. Now we transfer this minus 28 at the left side. This is 2.71 sigma, and this is now we transfer at the left side. So 28 is equal to 2.71 rho. So 28 divided by 2.71 is equal to rho. So which is nothing but 10.3 0.37 is equal to rho. So this is our standard deviation. Now we put this value in each equation to find out the value of the rho, means value of the mean. Let's suppose we put in the first equation. So this mu is equal to 35 plus 1.48 into 10.37. So this is nothing but 50 plus 34. So in this way we find out the standard deviation and the mean of the item. So I hope all you get idea how we solve the question on the Poisson distribution and the normal distribution. Thank you.